You in section 3.1 talking about quadratic functions, and in the previous video we left off and had graphed this function. I left all the work here so you can see that. One thing we did not do is we didn't talk about domain and range, so let me just quickly touch on that. The domain for this is going to be all real numbers, and for every parabola the domain, if it's opening up or down, if it's a function, should be all real numbers because it continues to get wider and wider forever. The range is what's going to change on all of these. In this case, the range goes from this value, which if you look at your y value is -8, and then everything up. And so it's everything from -8 to infinity, because again, that's minimum point there is a point with the y value of -8, and then it could be anything bigger than that. And so hopefully the graph will help you there, but I just want to mention that before we move on. So what I want us to do here is I want us to graph this function g of x equals -2x squared, and I want us to compare that to the graph of x squared and 2x squared. And so x squared is the one in red that you can see on the screen. 2x squared is the one that you see in blue. And so if we were to make a table, again, that is a pretty easy way to graph this. Let's put in 0 for x. And again, if you put in 0, 0 squared is 0, 0 times -2 is also 0. And then I'm also going to suggest we put in 1 and -1, because again, we want to see, since it does go through the origin, is that where the vertex is. Going left of that and right of that should give us an idea about the curve. So if we take 1 and put it in, and again, you can punch this into your calculator, just make sure you follow order of operations. 1 squared is 1, 1 times -2 is -2. And then we can also put in -1. So -1 squared is +1. 1 times -2 again is -2. And so if we graph this one, it goes through the origin, and then 1, -2, we're going to go right 1 and down 2, and then -1, -2, we'll go left 1 and down 2. And so you see this curve begin to take shape. Kind of looks something like that. And so if you compare that to the other two graphs that are drawn here, we would notice that where it's different from those is that it does open down. It is more narrow than the original parent graph, and so that is something that is unique, but it is the same width as the 2x squared. Because remember that number in the front tells us about how wide or narrow it is. And so if it's 2 or -2, the width is the same. It's just one opens up, one opens down. And so obviously in this case, you can see this one opens down. Okay? Now, the green graph that you see is the one we just did. And so now we want to compare that excuse me, to the one that's given here. So before we do anything, before we try to graph this, think about this form, there it is, that we talked about, and all these pieces. So remember that A is going to tell us if it opens up or down and how wide or narrow it is. The opposite of this -h will tell us to move right or left. And then the K tells us how much to move up or down. And so if you look at this equation, let's do the left and right and up and down first, because we know it's going to be a parabola, right? Again, we see the power of 2. This 5 tells us that this graph is going to be shifted up 5 units. Okay, so we know that we're going to go up 5 units from the origin. This +3, remember that's the same thing as minus a -3. That -3 part of that says we're going to move left 3 units. And so this graph if the origin, if the vertex starts at the origin and then it's shifted left 3 units and up 5 units, the vertex should be right there. And then the -2 tells us that it's going to open down. The width we know is going to match the blue or the green graphs that you see on the screen. So why is that beneficial? Well, as we're making a t-table and we're thinking about, okay, what numbers am I going to put in? Well, we don't necessarily want to put in 0 for x because we know the origin or the vertex should be at this point in red that we have on the screen. So let's start by putting -3 in for x. And if that is the vertex, if we go left and right of that -3, we should be able to get the curve. And so let's also put in -2 and -4 for x. And hopefully we'll see that curve begin to take shape. So if we take the -3 and we put it in, it's going to look like this. So just simplify that. Well, -3 plus 3 is 0. 0 squared is 0. 0 times -2 is 0. And that should give us +5. So the y value here being 5. And again, if you need to write all that out, I'll just quickly do it for you. So it's -2 times 0 plus 5, and that's 0 plus 5, which equals 5. Okay, so that's how we're getting that. And we're going to do the same thing with the -2 and also the -4. So if you take the -2 and substitute it in, we have -2 times -2 plus 3 squared plus 5. So -2 times, or -2 plus 3 is going to be +1 squared plus 5. We know 1 squared is 1. 1 times -2 is -2. Plus 5 gives us 3. What I think about that, -2, 3 is going to be here. Well, if we have the right point as our vertex, well, that should make some sense then, because it is going to open down. So hopefully the other point will give us the same thing. So we take -4 and substitute it in. We're going to have -4 plus 3 is -1 squared. -1 squared is +1. 1 times -2 is -2. Oh, it's plus 5. Which is +3. And so now if we plot each of those points, in this case we already have -3, 5. We've already plotted -2, 3, and then also -4, 3. We go left 4 and up 3. We're going to get these points, and again we begin to see this curve shape, this parabola shape, and we see what it's looking like. So how does it compare? Well, it's the exact same shape as the green one, the one we just did. It's the exact same shape, but it is shifted left and up. And so that's how it would compare to those. Obviously, it's more narrow than the parent graph. It does open down. So hopefully we can see all aspects of that. Now, again, domain and range. Domain here is, again, all real numbers, because it does get wider as it goes left and right. And then the range is going to be from this value, this top value of 5, and down. So it's everything from -infinity up to 5, and 5 does get the bracket. Okay. Again, if you have any questions about any of that, let me know. We're just using a table to do our graph here. Alright, so this time we're going to graph, but this time we're going to graph by finding the intercepts. And so if you remember when we talked about lines in chapter 2, we talked about finding the x and y intercepts. X-intercept being where it crosses the x-axis, y-intercept being where it crosses the y-axis. Those points are some beneficial points for us when we start trying to figure out what the graph is going to look like. So in this case, it's easiest to start with finding the y-intercept. So remember, f of x and y are the same thing. And so to find that y-intercept, we're going to take 0 and put it in for x. So if you were to do that, the equation is like this. And 0 squared is 0, and 0 times 2 is 0, plus 0 minus 6. And we find out that negative 6 is that y value. So the ordered pair here for the y-intercept, this is the y-intercept, is 0, negative 6. Okay? So, as we plot that point, we're not going to go right or left any, we're going to go down 6. Now, what do we know about this graph? Well, we know it should open up because that leading coefficient is a positive 2, so the positive part of it tells us we're going to open up. It also is going to be more narrow than the parent graph because it is a 2. It's bigger than 1. And so you can kind of keep that in mind. Now, to find the x-intercept, there are 2 of them because, again, as this is a parabola, we know this thing's got to go up, and this is wide, just kind of as a sketch, and it's got to go through the x-axis at 2 different points, again, because it's a parabola. So as we are thinking about finding that x-intercept, or those x-intercepts, well, we're going to put in 0 for y. Remember, f of x is the same thing as y. So we're going to say 0 is equal to 2x squared plus x minus 6. And we can solve that quadratic equation. We've solved quadratic equations for a long time now. And so we can solve it by factoring. You can do the quadratic formula. I don't care how you solve it, but you need to solve that equation. And so I'm going to solve by factoring. And so we'll take the 2 and multiply by the negative 6. And we'll get x squared plus x minus 12. And then we'll factor that. 2 numbers that multiply to give 12, that subtract to give 1 will be 4 and 3. Signs are different. The biggest number gets the positive. And then we multiplied by 2, so we'll divide by 2. And we'll have x plus 2 and 2x minus 3. Now, remember, to solve a quadratic equation, you're going to take both factors, set them equal to 0. So we're going to say x plus 2 equals 0. And when you subtract 2, you'll get x equals negative 2. And then we're going to take the 2x minus 3 and set it equal to 0. Add 3 and divide by 2, and you'll get x is equal to 3 halves. Now, remember, these intercepts are ordered pairs. So for the negative 2, our ordered pair is negative 2, 0. And for the 3 halves, it's 3 halves, 0. So we're going to plot those. The negative 2, 0 says we're going to go left 2, and we're not going to go up or down any. And the 3 halves says we're going to go right 3 halves, or 1 1/2, and then not go up or down any. Now, let me zoom in on this graph, because I want you to notice something. Remember that the parabola is symmetric, right? There's an axis of symmetry, and on the right side, it's the same as on the left side. If this y-intercept, this point at the bottom, if it were the origin, then as this thing goes up and goes up through this point, it would go up the same amount over here and go through that point. However, it doesn't. And so, because of that, we know the vertex of this parabola has to be shifted over. And so what we can do is, we don't know exactly, let me zoom this back out for a second. So we don't know exactly where that vertex is. We could find it. But what we do know is that it is somewhere close to this y-intercept. But it's really going to be somewhere down in this area, because we're going to need to be able to go down through this y-intercept, but then quickly back up. And so as you do your graph, you don't want to do it where it goes just to this y-intercept and then back up. It's actually got to go down below that a little bit. And so the graph is going to look something kind of like that. Again, it's not a V shape. It should be a parabola, smooth curve. Mine's not a great drawing. But my point is that intercept is not necessarily the lowest point. It's not necessarily the vertex. Now, we can find the vertex. We're not worried about that just yet. Okay, we will get to that coming up pretty shortly. If you have questions or anything about how to graph this one using the intercepts, please let me know. Shoot me an email. I'll be